My name is Dave Davenport. I'm the CEO of MotherG. Thank you for coming out today. We have an interesting conversation that we're going to have with Frank from Memex, with maybe Rose of Sharon helping him. So Frank Jones, Rose of Sharon DeVos, thanks for coming. We're going to talk about digital transformation. On everyone's table, there's a sheet that looks like this. Who can tell me what digital transformation is? Anyone? It is one of those terms that's used very frequently in IT worlds, technology worlds. I think it is a term that's overused. It's kind of like somebody in marketing, like Mike Vizo, came up with a term to apply to something that we've been doing a long time. When I started, when I graduated from college and I started at ADP, my father's company was a small manufacturer, and they had a computer system that only did GL, and it was a green screen from ADP, and the accountant went in and entered all the payables and receivables, and that was the level of computerization. He had a 5-part carbon form that we used special typewriters. I forget which the IBM Selectric version was, so that it could punch through all 5 copies. And then he would break those copies up and they would go to different departments. And that was how he ran his business for many years. Carbon paper was the biggest innovation from his grandfather to him. Flash forward a few years, and that now is a computer system. Right? Now those orders are being entered into a terminal, and those orders now are moving through the accounting department and the customer service department and the order entry department, and they're moving through those systems electronically. Right? Saved a lot of time, reduced errors, made it easier to find orders. They print out a bill of lading and an order for the shipping department or the production department. They would go and fill that order and proceed it through. That was the start of digital transformation. Actually, the ADP system was the start of a digital transformation for his company. So he's long since sold that and moved on. But who had email in 1990? No one. Because it really wasn't, there was this messaging thing within computers, but nobody really had email, right? Voicemail, I remember my first job, that was a big, new solution that we brought in. I used to get all these little pink slips when I'd get to the office, right? I'm old, by the way. So when you think about digital transformation, it's really the process of bringing technology to certain solutions in your organization that can bring value, automate for various reasons. So it might be to cut costs. It might be to improve accuracy. It might be to automate certain processes. Again, usually to improve costs, improve accuracy and quality. As you think of digital transformation, though, it transcends maybe the traditional thoughts. We can take a robot, or we can take a CNC machine, we can have it do a number of things today that we couldn't do 20 years ago in automating those processes, but yet we don't necessarily know what's happening in that machine while it's operating, right? We know it, turn it on and then 10 parts spit out of it and we say, cool, but we don't know how those parts were made, if there were errors with it. We know that the machine is running or not running, but we don't know how well it's running. We don't know how the operator who's running the machine is performing relative to that process. So there's a number of variables that we don't necessarily know about that go blind in that process. And you can think about this well beyond machines. We can think about it in other operations like marketing. We sent out a lot of marketing materials. What happened to it? We sent out 10,000 email. Did we get any leads? What happened to the emails that we sent, right? So as you start thinking about the processes in your organization, this just is a very simple way of starting to think about digital transformation. You can start asking what, why, and who as you think about processes that might need attention, your organization as a whole. So as you're thinking about your organization, thinking about different areas, one of the things that we're going to talk about today is Memex. And we came across Memex with Rose of Sharon, who was a past client of ours. And it's really a compelling solution for those of you that have productions, especially machine-based productions. I can tell you we're a human capital business. We have people who fix computer problems, help you align technology to your business and make it work so that you don't have to worry about it. In that process, we very much rely today on KPIs to tell us how those folks are performing. Are they performing well? Are we preventing problems? Are we aligning technology? And because of that, we track a lot of KPIs, a lot of measurements around that process to make sure that we're delivering against that value proposition. And when I think of a lot of our clients, in a sense, I'll exaggerate the point, they kind of put a lot of raw materials on the front end, put some people in there, and then kind of hope that on the back end, everything comes out just fine. And then they measure what comes out on the back end and say, oh, that isn't exactly what we thought. Let's go and try and figure out how and why and what happened there. And that's inefficient, right? I mean, it's, you got wasted product on the back end. It didn't come out right. You want to fix it real time. You want to get in the middle of it. And I know in our business, it's essential. And I think in manufacturing, when you have the investment in machinery and equipment and processes and intellectual capital to produce all those things, it's even more important, more critical to have real-time reporting and visibility into that. So the good news for all of you is you may not have known what digital transformation was or too scared to offer your opinion, but you have in fact begun the journey of digital transformation by exploring some ideas today. So that's the good news for you. I'd like to introduce Frank. From Memex, we're going to get a lot deeper into understanding how you can gain visibility into your production operation. And I think the best way of putting it is before you invest another nickel in more assets, consider juicing more out of what you already have. And I think that's the fundamental of what we see in Memex and why we're excited to introduce them to our clients and to the market as best we can. Frank?
Thanks to everyone, first of all, for coming. I'm sure I'll thank you a couple times. One of the things we want to talk about today is everybody in this room has probably heard IoT, Internet of Things, Industry 4.0. The basic premise here is the convergence of all that is what we call digital data-driven manufacturing, DDM. And that's what we're going to hear talk about. And what I want to do is try to give you a little bit of slice of where we see continuous improvement going. One of my colleagues, if he was here today, would tell you that if you're not collecting data directly from the machine in real time, you are not practicing lean, period. That's their opinion. And of course, that ruffles some people's feathers sometimes, but I think as you see how we're going to set this up and some of the things we're going to show you, you're starting to see the direction of why our former CTO is actually corrected in that very broad-based statement.
Please turn to the next slide.
So what we want to talk about is I'm going to talk a little bit about some 5 steps to how we connect to our shop floor. This is part of the discussion today is going to be on how we do this, and then we're going to get into the why later. Also, I want to talk a little bit about how this ties into continuous improvement. And does everyone in this room know what OEE stands for? Is everyone familiar with that term? Anybody? No. OEE is overall equipment effectiveness. And to Dave's point, if you do not have necessary CNC machines on your shop floor, if you have stamping presses, press brakes, heat treat ovens, EDM machines, assembly lines, manual and automatic, these are all assets we currently connect to. So don't think this is strictly to a machine-based discussion. If you have assets, I don't even use the word machine anymore, that you want to connect to, we have a way to do that.
Skip to slide 4.
Okay, so how do we connect on the shop floor? So there's 5 steps here. Talk about the connection. We're going to talk about how we visualize the actual data. We're going to produce data in real time. The whole point of why we want to talk about this is once we get this data, we want to see it and be able to consume it in the way that we want. Number 3, we want to be able to analyze the data. It's nice to have all this data, but what do we do with it once we have it? The last portion is also what is the optimization? How do we look at the process in a couple different ways to optimize it? We've got data, we've analyzed it, now what are we going to do to effect change on our shop floor? The last portion is actually our value proposition.
Please turn to the next slide.
Okay, so within our context, and what I think you're going to find, if you're not, those of you who may not be familiar with this, there's several protocols in manufacturing that are getting very much traction. If you're not familiar with the term MT Connect, that's an open source protocol. So think about 20, 25 years ago, if you have a group of machines on your shop floor from different OEMs, which is pretty typical in the shop floor today, they all spoke their own languages. Nobody spoke the same language. So a group of people, including our current CEO, our past CTO, and current CTO, among other people, got together and said, well, wouldn't it be a great idea if we commonized the data so that everybody in these machines can all speak the same language in a royalty-free open source protocol that you all can consume free. And that's what they is. So MT Connect Institute was born about 11, 12 years ago, and the first alliteration was written. So now this protocol, as we sit here 12 years later, has been established by a number of OEMs like Mazaks, Akumas, Makinos, Morisikis, a number of other companies. So that is a protocol that is directly read from the machine. Why is that important? Because we're talking about real-time data, and also this data stream is extremely large. There's a number of data points we can pull from a machine. FANUC Controls, if you're not familiar with, is actually the largest controller manufacturer in the world. They're owned by General Electric. And what happens is they have a protocol called Focus, same type of situation where now we can extract data directly from the machine in a real-time manner and also a large data set. The third one on top is OPC. That's been around for a while. Many of you may have PLC-driven pieces of equipment, like a Siemens Control or an Allen Bradley. This is another protocol that Memex can actually read natively. So what happens if you got some legacy piece of equipment that's 20 years old? Well, bottom left-hand corner, we have a hardware board, which I'll leave up here. If you guys want to see it, I'll pass it around. We make this piece of equipment. This is our IP. We assemble the board and we install it. And that is our way to connect to everything else. So if you have a heat treat oven, or if you've got a gear hobbing machine that's 40 years old, that's how we'll connect to it. That will make, that particular board that gets passed around will make your legacy piece of equipment a web server. That's pretty much the best way to describe it. We're going to talk a little bit about when I do the demo. People do have input into our system. The operator knows things the machine is not going to tell us. So we'll show you how we capture that information. And we are a fully vertically integrated system. We can connect to your ERP, MRP, Kanban system for work orders and product standard transfer down, so we can measure true OEE. That OEE moniker I used earlier. If you want to understand, and that's the most popular form of data collection as we speak here today, you have to be able to associate in our shop floor a worker to a work order to a machine. That's how you start the process to collect OEE, and the ERP system is the start of that process.
Please turn to the next slide.
Within the system, what you're going to hear, and most of you have probably heard the terms, you can actually store this information on the cloud, so that we do have a cloud option for our software. But we are primarily what's called an on-premise solution, which means the server is sitting inside your four walls, and that's behind your firewall for the obvious reasons you're probably familiar with what the cloud may give. However, within the system that we're talking about here, you have unlimited data views. So if you connect 4 machines or 400 machines, it doesn't matter to us. You have unlimited data views, which means you could have large screens like we're showing here on our demo here today, out on the shop floor showing a group of machines, a section of the plant, the entire plant, whatever it is you're looking at. You can also have this on your PCs. And also, since our dashboards I'm going to show you here in a little while are actually URL pages, This could be formatted if you have the right certificates to be able to see it on your phone. So you could be outside the plant, you don't have to VPN, if everyone knows what that is, you don't have to VPN the plant anymore. You'd be able to see dashboards remotely, so to speak.
Please turn to the next slide.
Okay, so this is a discussion in terms of how we analyze. There's a full reporting engine behind our software. By the way, our software's name is Tempest, Tempus. That is Latin for time, because that's what we're doing, measuring time. So what we want to do is be able to slice and dice the data a variety of ways. We're not report writers at Memex, so we created a number of templates that you can build off of. But you can see you have the ability between a shift, a person, a machine, a work order. There's a variety of ways to slice and dice data in our system, all because we're tracking it in real time from the machine. It gives you a multitude of ways to be able to select the data.
Please turn to the next slide.
One of the things we've moved in, and we talked about machine utilization, as Dave talked about before, is you have, is the machine up or down? If it's down, why is it down? That's machine utilization. Very high level, look at the data. But as time's marched on, people are now asking us, well, if you have a situation, if the machine's actually running, why isn't it running at 100%? It's running, but it's not 100%. How do we analyze that? So we get into feed rates and rapid overrides and things of that nature. So we're starting to analyze the slow condition, running but not at 100%. Because we need to know when that system is not running optimally, and if it's down, why is it down? Quite frequently, it's a pretty well-known speaker on the subject. All the calculations
Please turn to the next slide.
Are all based on him. So basically, when you talk about a 1% productivity improvement, that's a 2% profitability to the bottom line. What does that mean? So I just found that extra 20 minutes or 30 minutes we were talking about earlier, that's an OEE improvement of that 1%. But if I turn around and say, well, now that I've identified that, I'm now going to stick more product on there, those numbers go up. So that's when you start to kind of matriculate through all that. That's where you start to see paybacks in our system of even 4, maybe even 6 months. I will tell you, I've never been, most of your shops, there's a couple people in this room I know, but most of your shops is, I will tell you, if you implement this and you use the data directly from the machine in real time like we're talking about, to get an IRR or even an ROI of less than 12 months is very attainable. We have numerous people who've done it.
Please turn to the next slide.
Okay? Before I go any further, is there any questions? I know we're going to have questions later, but stop me if you have a question, we'll go over it.
Frank, I got a question.
Yes.
How long has this tool actually been around and available for the manufacturing space?
You're talking about from Memex?
Yeah.
This is actually the 4th version of our software. So this goes back to, I want to say 2009-ish, it was our first original version. What I'm going to show you here, and the big difference of the current version versus what you've seen in the past, is that we sat down several years ago, and this is a 4-year process, and our development team and us sat down and said, well, look, what does our customers want to see? If you buy a software, it doesn't have to be ours, any software, what you don't want to do, the cardinal sin, is to hit a ceiling with it and not be able to use it. If we maxed out, we can't use it anymore. So we built an extensible tool called Tempest, so you could plug in things. So if we're sitting here 8 years from now, you guys can still be plugging in new modules and grow it. We have a full development team in Memex. There's actually 30, Rosa shared maybe 35 employees, I would say, in our company, 9 of which are development engineers. That's important. So there's always new stuff coming out that you have access to. Because one thing we know for sure, I don't know any of you personally, except for Dave, I think a couple other people here do, is that either one of 3 things is going to change. The people in your shop are going to change, the process is going to change, the machinery is going to change. So the question is, if you install this, how am I going to be able to roll with you? That's the big question. Because I'm going to ask you to make a pretty good investment, and if you're going to do that, I better have an adaptable tool you can use 6 years from now. That's what we developed.
I'm just going to add on a little bit, Frank, to what you're saying there. So I think this is one of the things that sets Memex apart a bit. A lot of companies are thinking, I only need to collect a certain amount of data, and they're only thinking of a limited amount of data right now, because they can't envision in the future that they're going to need other information. So what happens with data is that a little bit of data creates a person for more data, right? And more data. And so having the tool that can continue to collect additional information, I think, is really one of the differentiators for Memex, is that you're going to be able to, when you have a thirst for the next piece of information, that you'll be able to get to that piece of information. So.
Please turn to the next slide.
So next few slides are just examples. Again, what we talk about, half the battle here is visibility of the data. And what typically happens is we install add-on boards on shop floors like what you see here. And typically what you're gonna see is maybe a 3 to 6% productivity bump just because everybody's seeing the data. It's not Big Brother watching. It's just saying, hey, I'm looking at what Joe's doing across the aisle, and I wanna be on the green team, I don't wanna be on the red team. So the data being available, being able to be visualized has an impact. Almost always we see a little bump from that.
Please turn to the next slide.
Okay? Another couple examples, and these are all dashboards I'm gonna show you here in a little bit. But again, the consumption of the data is unlimited. So if you have 5, 6, 8 machines, it doesn't matter. We can have add-on boards all across the shop floor. This is one of our aerospace customers on the right here. If you notice, they actually have a 50-inch screen TV for every machine tool in their shop floor. That's personally overkill for me, but that's what they want to see. The point is you can consume the data as much as you want.
Please turn to the next slide.
This obviously our information that we feed in also can roll into Gemma boards, and we'll talk a little bit about Kaizen events here in a little bit, but I just want to give you an idea that this data, again, real time would replace your manual charts, manual data collection, because now it's all in real time. So when you have your stand-up meetings on a shift basis, you'd be able to talk about what happened last shift or yesterday in real time.
Skip to slide 16.
It's more of the same? Okay. Okay, so machine connectivity, I don't know where the board is, I circulate around. Without getting a lot of depth with this, I think the important thing to understand is that we don't want to leave any asset behind. There's a number of times, as I said earlier, where we talk to people and say, I want to be able to connect to this, can you connect to some object that still runs high production? We want to be able to do that. That's really the key here, is to making, as I said before, a legacy piece of equipment into a web server. And that's what we need to be able to collect data. We may only get 6 or 7 data points from an older piece of equipment. And maybe a new machine tool, a new press might give us 20. But this is still running important production. We have to be able to connect to it. So that we've always had this in our arsenal. I think the general view in our company is that eventually, maybe all in our lifetimes, we'll see that the direct software connections will overtake the legacy equipment. But right now, the average shop floor is probably 60% legacy, 40% new. So we have a ways to go. There's still a lot of old equipment that still needs to be connected, that's still running high volume production.
Please turn to the next slide.
So there's a couple of pictures here. We'll skim through these relatively quickly. I just want to show you how they're connected on the back end. I know it's a little more techie side, but just give you an idea on the back end of your machines, how we can connect in some different links. So you can just scroll.
Skip to slide 19.
And if you go back maybe one real quick, this is actually a prime example. This particular OKK machine is, at the time this picture was taken, was about 28 years old. So you see, you still have the ability, as I said, to include this in the data collection, what we're doing with brand new machines. So it's a big advantage for us. And I will tell you the board, wherever it's floating around here, we have 2 competitors who don't have the ability to connect to legacy equipment, so they buy our board all the time. It's an open source protocol. We'll sell it to anybody who wants it, and they'll use it to consume their data the way they want.
Skip to slide 21.
Okay. So ERP integration, whether you have an MRP system, a Kanban, or an ERP, MRP system, we have the ability to connect to that through 2 pathways. The older way to do that is what's called a flat file transfer. So you would actually set up kind of a triangulation and say, here's a group of files that jobs are going to run, say we're going to push them down to a file share. That will trigger us to execute everything on the shop floor and push it back up. That's kind of the old way to do it. It still works. That's the old way to do it. The new way is, with Tempest, we built, I think we had like 500 API calls, and that's more of a direct way to connect work orders into our system. The difference between the two is basically this. If you have a file share and you guys release work orders at 8 o'clock in the morning, so just say 10 of them, okay? And we run those 10. Unless you update that file, we don't see anything else the rest of the day until you update something. API calls are a little different, is you run those same 10 jobs out to us, but then all you say, hey, we got a rush order, we got to push it into the system. The API call will come directly to us. We'll be able to see it instantaneously, schedule the job, and away we go. That's the big difference. So the API call version, and everyone who has ERP systems here, they have API calls now. If you have the latest versions, whether it's Epicor, Global Shop, GodBoss, E2, it doesn't matter. They all have these RESTful, what they call APIs, which are coupling agents to get this data more instantaneously.
Skip to slide 23.
Okay. So, in our world, continuous improvement starts at the fact that we're connecting directly to the machine in real time. So I want to go through some examples here is, if we have that information, then we're able to say, okay, what machines are running the jobs the best? Where's our bottlenecks? You can see how it opens up. I'm not gonna read all the slides, but you can see ultimately where's the hidden factory on the shop floor. It's opening up a whole plethora of different avenues to review the data.
Please turn to the next slide.
So obviously, when you have something like this, you want to look at root cause analysis. We're looking at better uptime, and again, all of the hows that we've been talking about now start to become visible.
Please turn to the next slide.
By the same token, we can identify bottlenecks. We can look at, in our data, what we want to see is we want to see all the unscheduled events that have some cadence to it. If I see an e-stop alarm in an hour 4 times on a machine, that's probably a catastrophic failure. There's something probably really going wrong. I need to address that. Our system, that will be visible to you right away.
Please turn to the next slide.
Okay, so as I mentioned earlier, we kind of look at the CI portion of this in terms of performance management model. What does that mean? As I said earlier, if you have people, process, or machinery that change, you have to be able to change with it and understand that the down reasons we're going to track on your shop floor are all configurable, okay? So if you have configuration, we need to know where they fit in the buckets. The 6 buckets on the bottom here between machine shop, job, maintenance, and reporting, all these different down reasons fit in different buckets. So it gives you a direction to understand where you need to attack the problems. So a down reason for a job may not be relevant to looking at anything in terms of a maintenance situation. It can be totally unrelated. That's why we made a configurable tool so that the down reasons that each of you want in your shop floor can be totally different on the same piece of equipment, because no one looks at the data the exact same way.
Please turn to the next slide.
Okay. So I talked about how we affect Kaizen events. Does anybody here run Kaizen events on their shop floor? Does anybody know what that is first? I guess is my first question. Hey, you guys do? Today, why don't you just real quick, can you explain kind of what that is, just for everybody's sake, if you would?
Basically, the Kaizen events are basically when you're going out and resolving issues or enhancing things that you see. So we start out by doing GIMA. When we have our GIMA meetings, we identify those problems, root cause, and then we go out with Kaizen, and everybody formulates those ideas, and we go out and we implement those ideas to try to resolve this.
Okay. But is it safe to say, though, Dave, the first couple steps is collecting data at the machine, right? In a manual way, right? Okay. So let's think about what Dave just said and what I'm relating to you. So that means that Dave's going through, and anybody else is going through basically a 7-step process. First 2 steps is collecting data, right? Understanding what that's saying, formulating a solution, implementing that solution, and making that part of standard work if everything goes okay. That's the basic formula. Okay, so what I'm saying is, if you go ahead. So we're gonna lower this down by 2 steps, because we're collecting data from the machine in real time, right? So now we're cutting the first 2 steps out. So why do I put up there and say, well, it's a continuous Kaizen? Well, if you have the data already and you're gonna make a move on this, now what I'm saying is, let's look at the solution, implement the solution, see if it's part of standard work. We've shortened the cycle on that to a large degree, because if anybody knows, if you walk on the shop floor and start watching what an operator's doing, they're gonna get a little nervous, they're gonna perform differently than they normally do. And so what we're trying to do is shorten that cycle so that you can get to the root cause analysis and the changes that you wanna make on the shop floor, and not focus on the data collection. We're already giving that to you.
And if I can say one more thing, what you're hitting on is very accurate. This morning, I'm asking a guy, hey, we had a bad variance on this job a week ago. What was going on? And he's trying to figure out what he was doing. The program was trying to figure out what they were doing, and it wasn't real time. That information would be real time, it would be at your fingertips.
Exactly. So this is one of the key takeaways, is that at some point you're going to use some methodology for continuous improvement on the shop floor. So if you have lean managers, you have continuous improvement people on your shop floor, this is what they do all day long. This is what they're looking to get to, and we're trying to shorten that cycle with real-time data from the machine. I know I keep repeating that, but at the end of the day, that is the foundation of everything we're doing.
Please turn to the next slide.
We might have to get through it. Okay. So again, kind of what Dave just touched on a little bit. The idea is to get away from the talk arounds after the fact type situation. Let's look at the reports. What does the data show us from an hour ago, and we can figure out what we need to do. So I don't want to belabor the point with that. I think that's understood. Good. Okay. So I'm going to show you an example. There's a full reporting section, as I mentioned earlier, in our system. If you click on the bottom, like there should be a start button there for video, or click in the square.
Please click the video link sent to you in this email.
Let me just narrate this because you're not going to be able to hear the voice, but I want to show you how you can use real-time data reporting system. And this has got a reporting system in our Tempest. And what you're going to see is one of my colleagues created this. He's just going to look at a very high-level view of data and how he's able to drill down in a matter of a couple minutes. So this is a group of machines, and he can see on July 5th, if you can read that, there's a big dip in utilization for the day. So now he wants to drill down into a group of machines and understand where the problem potentially is. I should mention everything we're showing here, this is stuff we train people how to do. You can see the CNC mill is down near 15% utilization. It's dragging the entire department down, which would not be visible to you if you didn't have the direct connection. So now what Tim's going to do is he's going to drill down into that particular machine and see he has 13 hours of maintenance on that particular machine, okay? So now the question we talked about before, is that a one-off event or is that a cadence of series of chronic problems that we need to be aware of? So now he's going to drill down just on that machine, that date, and you can see he's actually got 5.5 different events, 13 hours, but now there's a data log that says there's 5 separate events that occurred that gave you that 13 hours. That means we have a chronic issue. And everything we just showed you in that report, that was all done in less than 2 minutes. That's how you can go from a very high level view to one machine, one instance that's dragging the entire department down. It's an excellent example of what we do.
Please turn to the next slide.
We talked a little bit earlier about OEE, overall equipment effectiveness. There's 3 KPIs, which Dave talked about KPIs. Availability is machine utilization. Is the machine up or down? If it's down, why is it down? As a percentage of the total shift. So if we're running a shift and we're down for 4 hours, we got 50% utilization. Quality is good parts versus bad parts. And the performance is you have a certain product that you're producing, that you have a product standard to say, it takes me 10 minutes to produce this part on a regular basis. In our system, you can run the reports 6 months down the road and say, I've run this part 50 times. And it's 10-minute cycle time. How am I doing against that 10 minutes over a period of time? If I'm running at 9.5 minutes, well, let's change the product standard to 9.5 and start that whole exercise all over again. There's nothing really, I don't like to use the word sexy, but I guess that's what it is, about what we do. But if you use this data, it is brutally effective. And because it's right from the machine, there's no subjectiveness to this. It is what it is. And if you use it properly, it will show you the hidden factor that you are currently not seeing. Okay?
Please turn to the next slide.
So what drives, again, some of the things we talked about before. Let's take our digital transformation, let's get away from manual data collection, subjectiveness, and get information directly from the machine, which is where we need to start our digital journey from.
Please turn to the next slide.
So what we're looking at here is kind of what we typically see, what's the desire. So you can see the buckets on the far left. When I go into shops, and I've toured a number of places over the years, most people will say, if I ask them what their OEE is, I usually get a number north of 60%. The reality is they're probably about 34 to 35%. Understanding that 85% is world-class. That gives you the gap. I will tell you that if we come in and we talk about those incremental improvements, if you improve just 4, 5, 6, 8, 10% utilization, that is a huge, huge number. It probably pays for our system a couple times over. And so moving from 15 to 20 to 30 to 50% is a game changer for a manufacturing company, no question. So the desire and the goal here is to get on the right side here, get up to that 85%. We have some companies who will run close to that periodically. And think about what we're talking about here in terms of data. That if you are running the left side and somebody says to you, well, hey, we need to buy more equipment in cell number 6 because we're at capacity, but you see they're only running 30 to 40%. Somebody like Dave, who's got that type of responsibility, says, sorry guys, we're not buying it. We need to do better with what we have today, right? Or our data will show the flip side, is that, hey, no, we're actually at 70%. We need to think about buying more equipment. The data is driving these decisions. It's nobody's opinion. Data is showing what's actually going on.
Skip to slide 35.
Yes?
I just want to speak to that for a minute and touch on the cultural change that brings, what you were just speaking about, Frank. When the data is driving the decisions, then culturally this has a major impact on every manufacturing company. It becomes far less personal, and people feel validated, that you'll at first you'll see the operator have a position that it's changed, it's Big Brother, they're watching me, right? Then, and then as they begin to use this data, they begin to say, oh, it's validating what I've been trying to say all along. I know that we had a problem with such and such when nobody ever listened, or I brought it up one time or two times and then nothing happened. But when everyone is surrounded by the machine data, it really helps bring continuity and a good company culture as well. So I just wanted to throw that in.
Absolutely. So, again, there's basically 9 operation areas, and we're gonna get into this. I'm gonna show a quick demo here. I'm watching the clock a little bit, so we need to get the demo here shortly. But there's buckets of areas that we need to look at, whether it's actually what's going out the door, operational costs, and things, all things we're gonna touch on that on the demo. So I just want you to be aware, and also mention that I'm sure Michael will put out a copy of this presentation if you're interested. We'll send you a PDF version of it.
Please turn to the next slide.
Okay, so again, the 10 to 50% value proposition, that's what our customers tell us. And I can send you, we have a number of case studies. Memex has within our total base about 250 customers. When I say 250, a company like PCC that's owned by Berkshire Hathaway may have 4 plants, that's one customer, okay? We're all throughout North America, obviously predominantly in the US. We do have a presence in Brazil. We do have customers in both Norway and also Spain. I will tell you all, which I don't know how everybody will take this, but basically we've opted not to sell our software in Asia for probably some of the reasons you probably would suspect. So that are, again, leaving no machine behind. That's really a key consideration. And understanding too that you have an extensible tool you can use for years from now. That's all like being on the list. I think I could go to the, probably go to the demo.
Please turn to the next slide.
Does anybody have any questions? Go.
So you talked about filling out paper, right, for 2 hours. What happens if a company already has shop floor data collection now, clocking in and off the jobs?
Like with a kiosk, like an ERP kiosk?
Yeah, just put a tablet.
Okay, so the problem, my first question is that connected directly to the machine?
No.
That's still manual data collection. The only difference is you're not using a clipboard. I'm not trying to be offensive, but that's.
I'm answering. That's just fine. So when you're talking about the shop orders being uploaded to what would you uploading to?
So when we're done, and I'll show you that, we actually have an HMI at the machine. So the operator, again, associates an operator to a machine, to a work order. When they collect all that information, they're done, okay? They're gonna hit closeout. That's gonna push that work order plus all the machine state information that we're collecting. That's all gonna ultimately get routed back to the ERP, MRP, Kanban system, whatever it is you're using. Because we want you to be able to, at some point, to say, what's the real cost of these jobs? How can we hone in on the cost better if we know what's really going on in real time, okay? By the same token is, because it's an extensible product, you may have third-party software that you're using. Maybe you have vibration analysis or tooling information that another software is providing that we're not connected to, but we would be able to pull that data through that API call I talked about earlier and be able to pull that data in and show that concurrently. So think of the fact that if you had a dashboard here showing the current state of the machine, current work order, all the parts produced, parts to go, time on the job, etc., and then maybe some tooling information in real time right next to it. You have a pretty good comprehensive look at what's going on in that machine right now in real time.
Yeah, I think that unlike data piece, and you're going to demonstrate that here in a few minutes,
Yes.
really is very powerful. When you can put unlike information next to it, then you can begin to see what the cause is, why is something running well, why did it stop, who was there, and it's all literally just in line with each other. It's a highly visual system, and that's where we're just going to head.
So let me give a
I
different
guess I
example.
need to, I'll dive deeper into APIs. I mean, it's like work instructions, design documents, all
Yeah,
of that.
that can be stored on the HMI. That's not part of the work order per se, but it's available as association to it. Yeah. Okay, let me show you the demo. So in the last 20 minutes, I'm going to show you some basic dashboards. Again, the premise here is twofold, that the dashboards I'm going to show you, the menu's actually up here, is that the dashboards are web-based. So they're a URL page, so you can share them however you want. There's a library here that you can share them. So anyone seeing any of these tables, you can have 6 different views of the same thing if that's what you want to see. They're also widget-based. What I mean by that is we created little tools, which I'll show you here, so you can configure the dashboards the way you want to see it. You don't have to just see it the way I'm showing it. There's different ways to configure it. We'll train you how to actually do that. So let me go to, start with this. So this is what we call machine data grid. So kind of like a souped up spreadsheet, if you will. And again, all data collected directly in machine in real time. So what you have is a group of machines, the current state of the machines, and these are not selected by us, these are selected by you. The down reasons are configurable. So if you say, I want to see idle, I want to see setup time, I want to see single block, I want to see interrupted, I mean, there's a variety of things we can look at. It's all configurable by machine. So a machine directly next to it can have 16 totally different reasons if you want. That's the open architecture of the system, okay? Shift information, we bucket everything by shift. Total uptime for the shift, this is the total time of the shift. Total downtime, which we'll get into in a minute. The uptime, if we have part counts, and then in this case, we're just measuring the utilization of the machine. So I can go in here and say, well, I only want to see the machines that are currently in cycle. I squish this list down and basically block everything out. It'll recalculate all this, and this radial gauge, which is a widget you'll see on top, will show only the aggregates of what's actually being shown. So if we scrunch this down to different machines, this will change the values in real time, and you'll see exactly what that is. So it's a very basic view, but it tells you a lot of information very quickly. So the question is, I want to see some detail, what some of these machines, why these, where you have 27 minutes or an hour and 20, where's this down reason stuff starting to get aggregated? Where can I see that? So what we do is we produce an event chart here, and you can see on the top, we can have the work order or the program. We all know that the operator selects a program on a particular machine. We can associate that to a work order and be able to track data against it. And then what you're seeing in real time, this is an hour-long timeline. And every time you change event, we go from in-cycle to idle to in-cycle to e-stop. We're starting to tell a story over the course of an hour, a shift, a day of what's actually going on. So that if we're sitting at our desk or at our phone, we see this. Remember we talked earlier about the cadence of unscheduled things. We start to see things like this, and what you're seeing here. I see 3 situations, and all I gotta do to understand what the detail of the event is, I click on it, and it gives me the operator was away for 2 minutes from the machine, okay? But I've seen that now 3 times, actually now 4 times in less than an hour. If I'm a manager, I might be start asking some questions. Why are you away from the machine? Do you need something? Do you not have a resource? Is there something else you need to have from us to support you? That's the first question I'm gonna ask. But this gives you a real, again, this is a historical situation. If you want to go back 2 weeks on these machines, you can see what that is. And then to Rosa Sharon's point, she just mentioned on the CNC bill, this TMAC, that is a tooling data. That's not our software. That is a third-party data collection that they're pushing into us so we can see. And this event chart is showing events when they change, which means as long as that tool number is number 1, this will run number 1 ad infinitum. But as soon as they change, the operator changes it to machine or to tool number 2, we're going to draw a line like you see here, and they'll start number 2. So if you read this vertically, you start to see, well, on the gap lathe, I was knee stopped at 135. That's the actual condition 2. It's this shift. I'm in the process of making a part count, but you see the part count is actually elongated because we're during downtime. So chances are good the standard rate is not being met here because we're actually in a down state at that particular moment versus what you see here, which is probably more indicative of what an actual part count is at 3 minutes. So you can see this starts to tell you a story. And from an engineering standpoint, this is what you want to be able to see because this is managing what's going on the shop floor through a group of machines. And then this is some of the widgets on the bottom we have set up for you. So the same machines, but now we have it grouped what the different down reasons are. And there's 2 ways to look at this. This is set up in minutes. It can be minutes, seconds, or hours. Or we can set up the y-axis here to be number of occurrences. So we could just say, as you saw earlier, well, scheduled maintenance was 86, but we can also turn this on to say, well, this was 3 events. So if you're a manager like Dave and says, well, we're only supposed to have 2 scheduled maintenance today, what happened on the third one? Why do we have a third one? Well, the data shows there was 1. He can now go back in the system and start digging that out. Okay. So when we talk about the event chart, you saw a group of machines, but we also have the machine details for that particular machine. So any machine that we have, If you want to get into current shift, current work order information, we can see that. So you can see the operator's Elvis, you can see we're in a scheduled maintenance situation, how long that particular state is now derived. Shift information, again, that total time, part counts, and if the utilization machine's obviously down. And then you could have, as an example, maybe a utilization chart that says, hey, I can see what's happened over X number of hours, days, weeks, and trend this out and see at any point in time what's actually going on in the machine. So this is more of a drill down view specifically to one machine. I'm going to take you the other direction. Now we're going to look at a full shop floor view. So if you were to give us preferably a PNG or a JPEG of your shop floor, what you could do is we'll place these widgets directly over the location of the floor. So when you walk in the office in the morning, you turn this on, anything that's not green is not good, whatever it is. And now you have the detail to say, hey, I know where I need to walk on the shop floor, I can see where the problems are. And a lot of people, managers, will use this as kind of their first view of the day, so to speak. But as I said, these are widgets, there's different templates. So these are very, I'm gonna move this up a little bit so you can read this. We got the gantry mill here. So you can see the real-time utilization is 84%, what job's being run, who the operator is, part counts, total time, etc. There can be less data on this, or there can even be more data if you want to see that. This is just somebody who wants to see a little more detail. And just so you know, that last screen I showed you where we went into the individual machine detail, if I click on any one of these, this will hyperlink me automatically to the next dashboard where that individual data was at. Okay? The last thing I want to show, because we're running out of time, is if we're running jobs, and this is kind of the important, kind of the roll-up of all of our data. Memex, our system Tempest, is not a schedule. That's why you don't see the word schedule up here, it's actually a sequencer. Because the ERP system is going to push down and say, in an ideal world today, this is what we're going to run. Each one of these lines is a machine. So the ERP will say, well, we're going to run this job first. Green is what's on the job, on the machine currently. And then everything in red is set up in queue. So the ERP has said, this is what we're going to do today, if everything goes the way we're supposed to go. However, we're monitoring what's going on in the machine directly. So what happens is that if we start to queue downtime on this SSP job, this whole chart's going to start sliding to the right, correct? So at some point, our system's going to know that if that continues long enough downtime, maybe this job over here, which is now 24 hours away from starting, will start to flash red in our system. Because what you're doing now on the shop floor is affecting that either starting on time or shipping on time. So we have a problem. So what do? So product standards say, most people's product standards say, what's the description of the part, what's the setup time, what's the standard rate, when you ship it, how many parts are required. The other piece that you're missing is, we ask what other machines are capable of running this job for the very reason we're just looking at. Because if we know that this NB job could be run here on this machine, whatever machine this is, we have open capacity there, right? Because you told us in the product standard you could run it on that particular machine. So why not move it over? Because you just got notification you're late. If you don't change anything else, it's going to be late. So you drop and drag this, so your production control people can actually drop and drag that job over to the open capacity and continue to run. So when the ERP system refreshes, they'll see the change. It's about how to get in. I don't know if any aerospace work, but when you work with Airbus or Boeing, one of their requirements is their suppliers need to show them how they're going to make on-time deliveries. Where's their portal? Show me that you got your jobs. Our jobs on your shop floor are going to make on-time deliveries. How are you going to do that? So they'll use a screen that looks similar to this. And at the end of the day, this is what it's all about, right? Getting stuff done, getting out the door on time, and giving you a realized view. So your production control people don't have to walk on the floor, go to machine to machine. How are you doing the job? Where are you at? They can look at this and they know exactly what's going on. Okay. I think I'm done. I think that's good. Any questions? If you're interested, I know we skimmed the demo a little bit. I'll be happy to do it again
So
for you.
why don't you and Rose of Sharon come up? Let's just field some questions.
Yeah, sure.
Who's got a question? You got to have a little bit I mean, it's a lot, right? I think, think of this. I think our first experience in putting in KPIs was that we took a lot of time to get the KPIs up and get them in place. And that was a lot of work, right? Fleet COO, he put them all together. And now we got this dashboard and you kind of go, all right, well, now we got it. What are we supposed to do with it, right? You start looking at all this data. Having the information, if all you do is look at it, doesn't do you any good, right? It's really about using that information to gain better utilization, better quality, better productivity, and use of those very expensive assets, right? Some of these machines, we have a client that each machine costs well over $1 million. If you can juice 10% more out of that machine, that's excellent. You start running out of capacity, right, Elizabeth? You start running out of capacity, and you start saying, oh, geez, we're running out of physical space. I can't really even fit another machine in here. What do I do? You know, and you start looking at extra shifts. Extra shifts are expensive. Maybe you're already full. And you start thinking about weekends. These are ways of you, instead of just doing those very expensive moves, but if you can increase efficiency by 10 or 20% out of that machinery, then all of a sudden you have a tremendous amount of capacity that, by the way, doesn't really cost you anything. So it's why when Frank talks about the return on these investments, you can have potential for huge returns on the investment that you're getting from Frank, because it's really about utilizing those assets in a more productive manner. But it's really important that you think through that process, because having the data alone is not enough. Getting the data is a lot of work, but now what do you do with it when you finally have it? Questions, thoughts?
I have a question. Rose and Sharon, and Frank, really, what is the reaction to prospective customers to this tool? I mean, at first glance, when we saw it, it was pretty impressive. It's like, how would you not invest in a tool like this? Where do you see people saying, no, this is not for us? And like, what does that pushback look like? Like, what is the resistance in the market?
Want me to answer that one? So some of the places that I see the resistance is people think, well, I'm not full, I'm not running at full capacity right now. I'm just a job shop, I have short runs, I do prototype work. So that's one of the places where I see the pushback. They think of it as pushback. But what I think those manufacturers are missing is that even if most of your time is spent in setup, for example, that is still a valuable metric of machine usage. So this is not just for the production house where you're running out full volume all the time. This also works in a job shop environment. And the other thing that I hear is, I already know what's going on my shop floor, right? And that one's pretty laughable, because what people find is they don't know what's going on the shop floor. You heard Frank mention the word hidden factory several times in the presentation. That's the terminology that we use. But truly, there are a lot of misconceptions, and the examples are just kind of funny. I work with ERP pretty extensively and understand the power of logging in when you start and your job and all of that kind of thing. But I work for a company that different operators had different perceptions of at what point in the morning do you log into a machine. And we didn't catch it for long periods of time. We had other situations where break time, some operators would clock out, some of them wouldn't. People had different perceptions of things, and you just don't catch these things easily until you have the real machine data. So, and Frank, do you have anything to add to that?
Yeah, I think the couple things I would add to that is that, and this is going to sound a little, I don't want to say arrogant, but because people know what this is about, I mean, everyone in this room has heard, we talk about IoT and data-driven manufacturing. I mean, everybody's heard at least something about it. I mean, we don't evangelize about this anymore. We have people come to trade shows and say, I've heard about, Ray's somebody I work with, I mean, people will say, I've heard about this, how does this affect my business? So it's not usually, no, I don't want to do this. It might be, no, I don't have the budget for it now, or we'll look at it next year. But we have a lot of people that come back to us over the period of time just because I think they understand they want to do this at some point. And that doesn't mean I'm not talking about ourselves. I'm just saying in general, they get buy from our competitors. But I think most people understand that this is where our business is headed one way or another. And the question is, understand that there's only about 5% of the machine tools in the world that are connected. So even if you work with us or somebody else down the road, you're still an early adapter. This is still an industry situation, it's not well matured by any stretch. And so let me, a quick example, because Mike's always telling me, hey, make sure you bleed an example. So we have a customer in Wisconsin, give you a good example how somebody uses our data. What they do is they run an operator utilization report. So they have all these stamping presses, about 25 of them, and Dave runs days, I run afternoons, and Rose is the night shift. Same job, same press, the only difference is we're 3 different people running those jobs, right? So the question they look at is say, well, we need to know who needs the training. So every week they run this report, and lo and behold, I'm the low guy in the totem pole. I'm running the least amount. So over the course of last year, I get some training, because obviously these 2 people are doing something I'm not doing, which I need to know what that is.
Working.
Right.
That's right.
So what's happened is, as you'd expect, as I said earlier, no big jumps, but we're all just kind of going like this over the course of time. And what they're doing is they want to be able to cross-train people to run any press on the shop floor. So they now have 12% documented utilization improvement in the operator reports that they run. Now, 25 presses and 12%, that's a pretty big number. And it's just an increment. There's nothing fancy about it, but they're looking at the data and saying, between the human capital, where's the problem? The machines are the same, the work orders are the same, it's got to be something that we're doing different. It's a good example of how our data is used.
Yeah, Frank, maybe for our audience, you could guide us a little bit from a go-to-market strategy, and not talk about financial, but from a timeline standpoint, explain to us a typical engagement with any of our audience here, how it works, how it should work as well.
So there's basically a 5-step deployment process. So let's assume we all agree to work together. And what happens is, the first thing is we need to understand if you can provide us a dedicated SQL database inside your shop. We do have a cloud option, as I said earlier, but most of our customers are on-prem. That means that the server's inside your building. So we set that up first. That's the first point. Wherever the hardware board is, depending on how many hardware boards you need in a deployment, our next step is we send a guy out to your shop floor to install those hardware boards on the legacy equipment. The next thing we do remotely is stage 3 is to connect the machine data. So if you have 16 different down reasons you want to look at a machine, we have to validate all those remotely. So we need to look in through the server. Somebody's on the shop floor saying, yeah, put the machine e-stop, put an e-stop. I can see it, and we validate each signal. It's a little tedious, but once that's done, all the data's accurate. The last portion is we do the training. We'll go through how to create these dashboards, how to use the reports, all the things I just talked about. That's all part of the training package. And then the last step is the ERP, if you guys decide at some point to connect to it. Most of our customers do not start out with that. They get to it eventually, but they don't start out with that. So to answer, Philippe, your question, to do all that step, depending on how big the shop is and how many boards we need to connect, on a short timeline, that can be done probably in 60 plus days. Long time, it might take up to 4 or 5 months, because it's a timing issue. When can we get on your shop floor to put the boards in? Because we have to interrupt production to do that. So that's usually the bottleneck. But to deploy this in less than 6 months on a large scale is certainly doable. We've done it a number of times.
I have one other quick, so our manufacturing operation, we have a really complicated, really high-value products that we manufacture. And it's a combination of some automated equipment, a lot of manual operations, and automated inspection. And is there a way that you work to sort of get that manual, like times and things like that you can look at some of that information?
Yeah, I ran out of time, but there's actually an HMI that I was going to pull up to show you.
Okay.
So what that HMI does is, as we all know, the machines don't tell us everything. So the people have to tell us some of that. So the assembly lines we have today is we have this operator portal maybe stationed per line or per op 10, op 20. I'm just using general terms here. But if you're able to do that, then the operator can select and say, okay, I'm logged into a job, it's op 10. When I'm done, I'm going to pass the work to you. So now it's over to op 20, okay? But if you incur some kind of maintenance or an idle time, you can make those selections. The only difference here is we're just taking the human capital in place of the machine and saying we're tracking that as a way to understand. Right, because that's connected back to the network and say, yep, when we're done at op 40, whoever's at op 40, we finish the part, we roll that up, it looks just like what I just showed you.
Yeah.
Okay.
Just
That's-
came from the difference.
The other thing too is that there's a timeline to that job, so even if they're messing around, not being diligent on pushing the button, you still know at the time it started with them and at the time it ended with them.
Right.
no matter what happened there, if that's out of standard, you're gonna have some visibility. Right?
So let's say instead of a work order, maybe my experience is maybe it's a playbook or a tack time you're looking at. You're saying, hey, for 70 minutes to produce this on 4 stations, how are we doing? So the dashboard can say, okay, I started out 10, and now we're decrementing the time down, right, all the way to 0, it never stops. But meanwhile, we're looking at the utilization for each station concurrently, and the part counts and the down reasons. So it's giving you a pretty good broad base of what's actually going on throughout that process. It's no different if you've ever been to an engine plant, how they produce engines. It's the same concept. I'm 10, I'm 20, I'm 30, 40. If something goes down, if you're collecting manual data, well, where are we down at? We got 8 stations here, I have no idea. But our dashboards just say, hey, we got a problem at Op 40. You can walk right out to Op 40 and say, hey, what's the issue? Why are you guys idle? Are you missing materials, raw materials, whatever?
Yeah, and I would just add to that, he didn't have a chance to show the HMI or the human-machine interface, that particular screen essentially, but it's a very highly configurable interface for the operator, and you're able to roll it out the way that you train the operator. So you bring in little pieces at a time. First, you're just showing them information, then you're giving them a chance to input a little bit of information, and then you can build on that, and you train the operator as you're changing, again, that cultural environment at your shop. You're building that around that operator portal, essentially. So, and that's it's a very nice way just to step your team into where this all goes.
Yeah, so it's, when I talk about leaving nothing behind, I mean, think about, we have customers, a lot of people who machine parts, they stamp parts, whatever, but, well, by the way, over in the corner is our powder coat line. Well, that's the last thing all these parts see before it goes out the door. We better track that, because if that's not running, everything else just gets backed up. So in your situation, which I suspect is the assembly is probably pretty critical, it could potentially be a bottleneck, and maybe that's what you need to track, because all this other stuff is flowing into it. Yep.
When would be critical times to really, any time is a good time to look at this and improving efficiencies, but what are the critical kind of decision points when you should say, wait a minute, maybe we should consider, looking at our operational performance rather than what?
I would generally say, kind of back to what I thought before, is that if there's an inclination that you're going to buy more equipment, and Dave will tell you, Ray will tell you, I mean, no exaggeration, some of these pieces of equipment can run millions of dollars. So it's a big investment. And one of my colleagues likes to say our cost of our software is a rounding error to that. It's pretty true. So I would say if you're looking to buy new equipment, doing the expansion, are you in growth mode to the point you've got to find extra capacity without...
So shift decisions.
Yep, shift decisions, adding extra shifts, new equipment. When the paradigm is changing, that's a good time to look at that.
Also, when lead times become critical, when you're missing on-time deliveries, those are also times when you definitely want to start considering this. I think this is really the future of manufacturing in this way. Future manufacturing is going to require everyone to be faster, right? We've got to be more flexible, be able to do smaller job quantities, and we've got to be able to get it out the door faster than ever before. It's that highly customizable environment now that we're looking at making things. And this kind of real-time information is going to be vital in the future for companies to be able to make smaller batches, quite frankly, and to make it faster than ever before. Because you've got to know minute by minute, you can't afford to waste the time anymore to get things to market. I mean, hey, Amazon's doing same-day delivery. What is that going to do to manufacturing?
Thank you for coming. Thanks to Memex. Nice job. If you care for the presentation, if you want a copy of it, just let one of the MotherG folks know, or Memex, and we'll get your business card and email you a copy. Any other questions, you can reach out to us or to Memex and take it from there. But other than that, make sure you have a cookie, and thanks for coming.
Thank you very much.